We're now looking at a teaching video on polynomials. The subtopic is comparison of terms. Here, let's go through some definition. An identity is an equation in which the expression on the LHS, that stands for left hand side, is equal to the expression on the right. The RHS is the right hand side. So basically, an identity would also have the expression on the left hand side, and this symbol is for congruency. So this is how we read it. The expression on the left hand side is congruent to the expression on the right hand side. There are two methods of finding the unknown constants in an identity. The two ways are, one is substitution of special values of x. The other way is simply just comparison of like terms. Comparison of like terms. For point 3, we are looking at the use of selective comparison of like terms. So over here, on the left-hand side of the identity, we have a cubic expression. And on the right-hand side of the expression, we have factors plus c. So the objective is to find the value of a, b, and c. So if I'm using the selective comparison method, I will not expand the right-hand side of the expression fully, except that when I need to compare x cubed terms, I'll look for the x cubed terms on the right-hand side of the expression. So this is how we do it. The full identity, on the left-hand side, I have a cubic expression. On the right-hand side, this is the arrangement. So first, I do the comparison of the x cubed terms. So on the left-hand side, I have 2x cubed. And on the right-hand side, to get the x cubed terms, I'll have ax times x times x. So I have got ax cubed. Therefore, the a value would be a 2. Next, I will look for the value of b. So I'll be comparing the x squared terms. on the left-hand side, I have 3x squared. On the right-hand side, if I need x squared terms, I would take ax times x times a constant. That will give me ax squared. Then, if I take ax times this x, I will have to multiply to the 3. So that will give me 3ax squared. Then if I'm looking at x times x here, then it has to multiply to the b. So bx squared. So adding these two up, I have 4ax squared plus bx squared. So removing the x squared, and on the right side I will have 4a. Basically it's just 4 times 2, and 2 is the value of a, plus b. Therefore b is equals to -5. So next and finally, to find the c, I have to compare the constant terms, or the constants. So on the left-hand side, I have -5. On the right-hand side, I can have b times the 3 times the 1, so that would be 3b plus the other constant c. So b is just a -5. So therefore, c is equals to 10. So by this way, you realize I've not expanded this, but chose to just compare whatever terms that I need to compare in order to solve for the constants of a, b, and c. Next, for point 4, we look at the full expansion of the expression in order to do comparison of like terms. Without the s, like terms. So, if you look at this question, the right-hand side of the identity can be step-by-step expanded. Of course, then we will compare the like terms, the x cubed terms, with the x cubed terms on either side of the identities. So here we only have a quadratic expression on the left-hand side. So what I need to do is to expand this. I have a times x squared minus 3x plus 2. So next is to group the like terms together. I only have one x squared terms. Then the x terms, the b minus 3a bracket times x. So here I have a times -3x, which is -3ax, -3ax. Here I have b times x, so bx, so b times x. So the x terms are all covered. Next, the constant term, a times 2, so I get 2a. The constant term here, b times -1, b. And then also the constant terms, c. So plus c. So It's not difficult to expand fully, but when the expression becomes complicated, sometimes there is no need to just have this full expansion. But it's the foolproof approach, because then you can take this like term, x squared term, compared to the x squared term on the left-hand side. So comparing the x squared terms, I would have a equals to 3. Next, comparing the x terms, I will have on the left hand side negative 11x, on the right hand side I have b minus 2a. So when I remove the x and substitute 3 into the a, b will become negative 5. Lastly, I make a comparison of the constant terms. On the left hand side I have a 3, on the right hand side I have 2a minus b plus c. The a value is 3 and b value is negative 5. Therefore, the c value is negative 8. So you can see in this method, when we talk about the use of full expansion of the expression in order to compare like terms on the left hand side as well as on the right hand side, we can do this: expand fully and then compare like terms on either side of the identities. Now we look at point 5, use of special substitution of values of x. Not submission, but substitution of values of x. Now, on the left-hand side of the identities, we have a cubic expression. So rewriting the identity, now this is what we do. Now if I need to work out the value of c, one way to do it is this. I can actually put in a 2 here, and therefore this whole expression is rendered 0. Or I can also, for simplicity's sake, put in a 0 for x, then this whole expression will also become a 0. And therefore I can solve for the c. So this is what I'll do. When x is equals to 0, I'll put into the x 0. All that will become 0. And this as well, all 0, c. Therefore, c is equals to negative 5. So that is what I mean by substituting special values. Now, next, of course, Now if I want to keep things a little easy, and I want to reduce this to a 1, I can put in a 3. Now, when x is equals to 3, then you can see a lot of these numbers will become very big. So I may not choose to do that. Now if I put in a 1, so all this will become more manageable. So the value that we choose must make the working a lot easier to deal with. So when x is equals to 1, I have 3 bracket 1 cubed minus 8 bracket 1 squared plus 4 bracket 1 minus 5 equals to x will be 1, then I have a plus b, then times the minus 1, because 1 minus the 2 is just minus 1. The c will now be negative 5. So 3 minus 8 plus 4 minus 5 equals negative a minus b minus 5. That will all cancel off. So I have a plus b equals to 1. Because negative 8 plus 4 is negative 4, plus the 3 is negative 1. I got negative 1 equals negative a minus b. Multiplying throughout by negative 1, this is what I get, and I make a the subject here. And I call it equation 1. Of course, next I have to choose another value. I can't choose 2 because it will reduce everything here to a 0, and therefore I will not have any information of a and b to work with. So the next thing to do can't be helped in this case. I have to use x equals to 3. So when I do that, I have 3 times 3 cubed minus 8 times 3 squared plus 4 times 3 minus 5 is equals to 3 times 3a plus b, and then a 1 here, because 3 minus 2 is 1, plus, or rather, minus 5, because c, as we found before, is just a negative 5. This is 81, 72, 12, minus 5. So I have 9a plus 3b minus 5. Again, that will go. Negative 72 plus 12 is negative 60. That would make 21 on the left-hand side. If I just divide throughout by 3, I have 3a plus b equals to 7. That's equation 2. So having these two equations, then I can solve for the a and the b. So substitute 1 into 2. The 3a, the a is replaced by 1 minus b. So I have 3 minus 3b plus b is equals to 7. Negative 2b is equals to 4. Therefore, b is equals to negative 2. So, having found b, I will then substitute the value of b into equation 1. So A is simply just 1 minus the negative 2. I get A equals to 3. So A is equals to 3, B equals to negative 2, and right at the start here, I found the value of C, which is negative 5. So for comparison of like terms, there are actually 3 ways. But to think it simply, the 2 major ways are substitution of special values of x, the other one, comparison of like terms. Under comparison of like terms, we can have just comparison by simply expanding fully the expression on the right hand side, or by selective comparison. So we have come to the end of this particular video segment.